Good morning, students. In the previous classes, we discussed the concepts related with force and laws of motion. The first chapter we discussed about the concepts of motion. Okay, we discussed position, path length, distance, displacement, speed, velocity, acceleration, and about the graphs, distance time graph, velocity time graph. Okay, then we discussed three equations of motions. What are the three equations of motions? Number one is V equal to U plus AT. Second, S equal to UT plus half AT square. Third, V square minus U square equal to 2AS. Okay, then we discussed uniform circular motion. All concepts are related with motion. The second chapter, that is force and laws of motion. This chapter, the second chapter also related with motion. Okay, we discussed what is a force, then what are the laws of motions, Newton's first law, second law, and third law. Okay, then we explained law of conservation of momentum from Newton's second and third laws. Okay, so today we have to discuss a new chapter. Its name is gravitation. Physics, third chapter is gravitation. Okay, we know about gravitation or gravitational force or gravity of earth. The term gravity is related with force. What is a force? A push or pull on an object is called force. Okay, what are the effects of force? To move an object, to stop an object, or to change the direction of an object, or change the shape of an object, we have to do something. That something is called force. Okay, so for all activities we need force. Okay, without the force we can't do any work. Okay, so gravitation is also related with force. Okay, we know about all objects are attracted towards the earth. All objects in this universe attracts each other, or all objects are attracted towards the center of the earth. That term is called gravitation. So what is a gravitational force? Gravitational force. What is gravitational force? Gravitational force is the force of attraction between objects. Okay, force of attraction between objects, that is called gravitational force. We know if a stone, for example, if a stone is dropped from a height, if a stone or a chalk is dropped from a height, it falls down towards the earth due to the attraction of the earth. That attractive force is called gravitational force, or it is simply called gravity, or it is called gravity of the earth. So there are many applications of gravitational force. What are the applications of gravitational force? We know all objects in this universe attracts each other according to Newton. So this gravitation is explained by a scientist, Isaac Newton. Okay, so what is gravitation or what is gravitational force? According to Newton, all objects in the universe attracts each other. That is called gravitational force or gravity. This law is called universal law of gravitation. This law is called universal law of gravitation. Universal law of gravitation depends two factors. One is mass of the objects. Next is distance between objects. Distance between objects. For example, we consider two objects. Object A, its mass is capital letter M. Object B, its mass is small letter m. The distance between them or distance between its centers is d. The distance between two objects, what? D. Okay. So the force of interaction or force of attraction between these two objects, that is represented by a letter F. F is the force of attraction between these two objects. That is directly proportional to product of their masses. Product means multiplication. Force of attraction between two objects is directly proportional to the product of their masses, and this force of attraction is inversely proportional to square of the distance between them. This is called the universal law of gravitation. Why this Newton's law is called the universal law? This law is applicable to all objects in this universe. Okay, all objects in this universe attracts each other with a force. That force is directly proportional to product of their masses and inversely proportional to square of the distance between its centers. This law is called universal law of gravitation. This law is called universal law of gravitation. This law is called universal law of gravitation. We can explain the definition of universal law of gravitation. What is the definition of universal law of gravitation? According to universal law of gravitation, every objects in this universe attracts each other with a force. That force is directly proportional to product of their masses and inversely proportional to square of the distance between them. Okay, so we can combine these two equations. Okay, so we get F directly proportional to product of their masses and inversely proportional to square of the distance between them. F proportional to m into m divided by d square. Okay, so F equal to, there is a proportionality sign. Okay, if we change proportionality sign into equals, so F is equal to G into m into m divided by d square. This is the equation of universal law of gravitation. F is equal to G into m by d square, where G is called gravitational constant. where G is called gravitational constant. Okay, then we can find an equation for gravitational constant G. So we can find G equal to, gravitational constant is equal to, d square is multiplied with F into d square divided by m into m. Okay, so what is the unit of gravitational constant? What is the unit of gravitational force? Unit of gravitational force is Newton. Then what is the unit of gravitational constant? So we can derive that unit from this equation. What is the unit of F? Newton. Unit of d means distance. Unit of distance is meter. D square means meter square divided by m means mass. What is the unit of mass? Yes, kilogram. So kilogram into kilogram, kilogram square. So this is the unit of gravitational constant. Clear? So now we derived an equation for gravitational force, F equal to G m by d square. Okay, so where G is called gravitational constant. Then G equal to F into d square divided by m into m. Okay. Then unit of gravitational constant is Newton meter square by kg square. Then what is the value of universal gravitation constant? Okay, so from this equation, okay, we can find the value of universal gravitational constant. It is found to be 6.673 into 10 raised to minus 11 unit Newton meter square kg raised to minus 2. Here is divided by kg square. Okay, so we can write kg square as Newton meter square kg raised to minus 2. This is the value of universal gravitational constant. Clear? Okay, so today we discussed what is gravitational force. Gravitational force is a force between two objects. Okay, we know according to Newton, every objects in this universe attracts each other. When this chalk is dropped from a height, what happens? It moves down or it falls down to the earth due to the pulling of the earth or due to the attraction of the earth. Okay, so we know what are the factors which depends on gravitational force. Gravitational force depends on two factors. One is mass of the object. Second one is distance between two objects. Okay, we know every object in the universe attracts each other. That means this chalk is attracted by the earth and earth is also attracted by this chalk. But the movement of the earth towards this chalk, we can't see the movement of the earth towards this chalk. Why? The mass of the earth is very, very high. Okay, very high mass. Okay, so the movement of the chalk towards the earth, we can see. Why? We can see the movement of the chalk towards the earth. Why? The mass of this chalk is very, very small as compared to the mass of the earth. Clear? So, all objects in this universe attracts each other. Okay, so gravitational force depends two factors. What are they? One is mass, next is distance between the two masses or distance between two objects. Clear? So then what are the importance of universal law of gravitation? What are the importance of universal law of gravitation? What are the uses of the universal law of gravitation? We know this law is universal law. Why law of gravitation? Why this law of gravitation is called a universal law of gravitation? This law is applicable to all objects in the universe. Okay, it binds us to the earth. Okay, gravitational force binds us to the earth. If there is no gravitational force, what happens? Okay, so if there is gravitational force, if here is a gravitational force, so we binds us to the earth. That is the first important. Second, we know all planets are revolving around the sun. All planets are revolving around the sun due to the law of gravitation or due to the force of gravitation. Okay, we know moon is revolving around the earth, or artificial satellites are revolving around the planets, or satellites are revolving around the planets. All are due to the law of gravitation. We know in the case of rain falling, what happened? Rain falls down to the earth due to universal law of gravitation. So earth pulls or earth attracts raindrops to the earth. Okay, so rain falls down to the earth, that is due to force of gravitation. Okay, the water flows in the river, that is due to law of gravitation, or that is due to force of gravitation. We binds the gravitational force binds us to the earth. All planets are revolving around the sun. All satellites are revolving around the planets. Okay, so all are due to the force of gravitation. Okay, it is explained by Isaac Newton. So Isaac Newton explained the universal law of gravitation. What is a universal law of gravitation? Every objects in the universe attracts each other with a force. That force is directly proportional to product of their masses and inversely proportional to square of the distance between them. This is called the universal law of gravitation. Clear? Okay, then what is the unit of gravitational constant? Unit of gravitational constant is Newton meter square by kg square. The value of universal gravitational constant is 6.673 into 10 raised to minus 11 Newton meter square kg raised to minus 2. This is the equation to find gravitational constant. F into G is equal to the F into d square divided by m into m. Unit of force is Newton. Unit of gravitational force is also Newton. Okay. So next we can solve a problem related with the universal law of gravitation. The question is, the mass of the earth is 6 into 10 raised to 24 kg and that of the moon is 7.4 into 10 raised to 22 kg. If the distance between the earth and the moon is 3.84 into 10 raised to 5 kilometer, calculate the force exerted by the earth on the moon. We know every object in the universe attracts each other. Okay, so we can find the gravitational force between earth and the moon. So what is the equation to find the gravitational force? F equal to G into mm by d square. First we can write given that mass of the earth, that is capital letter M, mass of the earth, 6 into 10 raised to 24 kg. Then mass of the moon, small letter m, equal to 7.4 into 10 raised to 22 kg. Distance d equal to 3.84 into 10 raised to 5 kilometer. Okay. Then this is distance is given in kilometer, but the standard unit of distance is meter. So first we have to convert kilometer into meter. So this is equal to 3.84 into 10 raised to 5 into 1000 meter. 1 kilometer equal to 1000 meter. So this is equal to 3.84 into 10 raised to 5 into 1000 means 10 raised to 3 equal to 3.84 into 10 raised to 5 into 10 raised to 3, 10 raised to 8 meter. So capital M 6 into 10 raised to 24 kg. Small m 7.4 into 10 raised to 22 kg. Distance 3.84 into 10 raised to 8 meter. Then what is the value of G? Discussed. What is the value of G? 6.673 into 10 raised to minus 11 Newton meter square by kg square. These are the given data. Then we have to find the value of F, gravitational force. F equal to question mark. So what is the equation to find F? F equal to G mm by d square. Okay, then substitute the given values in this equation. So this is equal to 6.673 into 10 raised to minus 11 into 6 into 10 raised to 24 into 7.4 into 10 raised to 22. Divided by d square. What is d? 3.84 into 10 raised to 8 whole square. Okay. So we just substituted all given values in this equation. Okay. This is the physics part. Next is the mathematical part. First you multiply 6.673 into 10 raised to minus 11 and 6 into 10 raised to 24 and 7.4 into 10 raised to 22. First multiplication. Then divided by this value square. First you find the square of this value, then divide with this answer. Okay, so we will get 2.01 into 10 raised to 20 Newton. The final answer is 2.01 into 10 raised to 20 Newton. 10 raised to 20 means 20 zeros after 10. It is a very, very big value. Okay, so the force of interaction between Earth and Moon is very high force. Okay, its value is 2.01 into 10 raised to 20 Newton. Okay, so today we discussed gravitational force or gravity of the earth, then universal law of gravitation, its definition and its equations. Okay, then we discussed importance of universal law of gravitations. Okay, so today we can conclude our class. Okay, thank you.